Welcome, everyone, to the American Space Museum. I'm your guest host, Mikey Haddad. I'm glad you're here to stay curious. Mark's on vacation, and so I'll be the host with co-producer Marty Winkle. Hey, Marty, how you doing tonight?
I'm doing fine, Mike. Thanks for
Okay,
being
great.
here.
Just a few things I wanted to mention. Of course, coming up, found out that they had to go for docking. So the Crew 5 is supposed to dock, I guess, at 4:57 p.m. Eastern time tonight. And then, of course, shortly after that, we're having the Galaxy 33 and 34 SpaceX launch at 7:07 p.m. And then for those of you in Brevard County, we actually got Space Station flying overhead about 7:59 p.m. So all kind of fun stuff happening this evening on the Space Coast, and just glad everybody's here. We'll be talking about tonight the payload, the Spacelab J payload that flew in September of 1992. Again, this was going to be done last month, but because of the storm now we had to delay to October, but it was a September launch. And so we guess we can probably, if we want to, Marty, we can go and just get into the first couple of charts. Okay, so this is the patch, the crew patch, showing again. It was a Spacelab J was basically a joint American-Japanese space lab. And again, we'll get into shortly about exactly what Spacelab is, but it actually had 34 experiments that flew. Let me get the exact details here. They had 34 sponsored by NASA, 7 by NASA, and then there were 2 collaborating efforts. One of the ones we're talking about, because we can't talk about all 34, we're actually going to be talking about the fish experiment. One experiment that dealt with fish. We had fish, frogs, and hornets that flew on this flight. And we'll focus on the fish part of the experiment, the one experiment that had fish. It was 2 koi carp fish that flew on this mission. Okay. All right. What I wanted to show here, for those that maybe, this is kind of the first time maybe trying to remember or trying to listen in on what a Spacelab is. This is a configuration of what Spacelab J flew for that mission. And of course, what you see is a shuttle. And inside the shuttle is a Spacelab module with the Spacelab tunnel. Again, this is a pressurized environment, so the crew would work from the front mid-deck area there, flight crew and mid-deck area. They'd go down through the tunnel into this pressurized laboratory in space. So basically, it's a search-leave environment in space. And in the very back is a getaway special bridge. It held 12 getaway special cans that flew. We flew those on a number of different flights. In fact, there was times when in the early part of the program where they would fly weight as ballast in the back of the shuttle. We found out, well, why don't we fly some science? And so some of these getaway specials would actually fly as experiments, but used to kind of help the CG of the shuttle. One thing I wanted to point out here is if you look up at the top left of it, you'll see kind of the inside cutaway views into the module. What's inside that module is called racks, which is the person you see kind of floating in front of one of those. There is actually 10 racks that held experiments and 2 what's called subsystem racks that made up kind of the guts of that. Now, I wanted to make sure kind of the area I worked in was called the Experiment Integration Level 4 group. And what that entailed was the experiment racks that went inside this module. Our job was basically to put all that together and make sure it worked before the flight. One thing neat about our group was we consisted of only NASA personnel for everything except the technician role. So normally you'd have an engineering contractor, engineering NASA, safety contractor, safety NASA. We only had NASA in our group called Level 4 Experiment Integration. Boeing was the only contractor and those technicians. And so we worked on basically putting this together ourselves. Now, we weren't the only ones. Of course, there's a lot. You can see there's a lot of hardware here. We focused on the racks, the experiment racks that went into this module. The module itself, the shell of the module, 2 of the subsystem racks, control racks that we'll talk about shortly, was done by McDonnell Douglas as well as the tunnel. And so there's a number of different organizations that kind of made this happen. We're just going to focus on kind of the experiment part of that. Okay. What this shows kind of the basic racks. Again, for people who are Spacelab veterans, this is probably a rehash, but for the people that are kind of new, this is what the basic racks looked like. This is how they'd come into Kennedy. In this configuration, we had a single rack, which is the 2 off to the left, and then a double rack. And depending on the mission, we could fly combinations of these, depending on what was going to fly. So this is how the rack started out. Came to Kennedy. We'd populate them with whatever was going to fly in that mission. After the mission, tear it apart and then repopulate these same racks. So these racks flew many, many times. Okay. This wasn't the one that flew on Spacelab J, but this is an example of one of the racks once it's all completed. You can see it's kind of stuffed we put as much stuff as we can in these racks. They want to fly as much hardware as they could. So it's just an example, one of the racks, double racks, once we kind of got it together. Okay, from there, we go into what's called a rack train. Now, if you look kind of in the center there, you see the gray kind of angled things. Those are basically the experiment racks. 10 of those. The two kind of brown ones in front, those are the ones that are control racks. Those are actually part of the Spacelab module, which is just down the building from where this is being done. Again, all this work was done in a horizontal orientation in the Operations Engine Checkout building, which is now the Neil Armstrong Operations Engine Checkout building. This is on the west end, called the Level 4. The module itself that contain these flight racks that those two tan racks are representing as ground support equipment, that was actually being done in the next stand, which is called Level 3. So the McDonnell Douglas group was preparing the shell of the module in those racks while we're working on the 10 racks experiment in Level 4. Okay, so that's kind of give you an idea. And again, from here, you're actually on the west part of the building looking east down the building. Again, Operations Checkout building at Kennedy Space Center. Okay, this next picture, excuse me, this shows the experiment rack train going into the module. This is kind of what we call level 2. This is where the shell of the module and the experiment racks kind of come together. And this is a picture of those racks before they're inserted into the module. And again, this isn't the Spacelab J, but it's one of the missions we flew just as an example. Okay, now kind of let's look inside. Okay, here's the inside. There's the two flight racks with the shell of the module, and you can see all that open area where the experiment racks would go. And so that kind of gives you what this is all kind of what McDonnell Douglas was working on, while we would then prepare the experiment part of it. Okay, now taking this and then turning and going 180 and looking the other way, this is what you would see. Okay, you can see kind of the control racks in the foreground. In the background, there's the angled experiment racks getting ready to slide in here to basically make a Spacelab complement. And that was done for basically Spacelab missions over and over again. Again, the racks themselves were reused, the floors were reused, the shells were reused. The things that kind of changed out was the experiments that would go in. And again, on this one with Spacelab J, we'll focus on the fish experiment that went in there. Okay? All right, this is a picture of the crew that flew on Spacelab J. Again, because our job was to test and make sure that all this was functional, 100% operational before flight, the crew would come down for that test, which makes sense. Hey, they're going to operate this stuff in orbit, come down for the test. That way, if there's any problems, hey, they have that same problem on orbit. They knew, hey, I was there. I know what happened. I could fix that. And so you can see they're actually suited up here in the bunny suits. They pulled their caps and that off for the picture. Early on in the program, the astronauts didn't have to do this. You saw some of the earlier pictures where they're in their blue suits. We found that, yeah, they needed to kind of suit up with the rest of us, even though they're very special people. And so this is a picture of them basically in the bunny suits. Again, for contamination purposes. When we went inside the module, you'd have to dress up like this in a full bunny suit. Outside, more of a smock, kind of a gown type thing. But when you're inside, this is how we suited up. And of course, the crew had to do that too. This is a picture just the crew. It's kind of a neat picture. Okay, this is one we're going to focus on. The carp. Two carp flew on this mission. And this is one of the pictures of the carp. This is actually a picture over in what used to be Hangar L. It's not even there anymore, on the Cape Canaveral Air Force Station side. That was controlled by Bionetics Corporation. They would handle, excuse me, a lot of the pre-flight handling of animals. I mean, this Bionetics group was an incredible group of individuals, very sharp, very smart, that would make sure that these animals were cared for before they were installed in the shuttle. And this is a picture of the carp. Again, oh, well, it's a carp in water. No, the water's got to be a certain chemical makeup. It's got to be a certain temperature. All these requirements to make sure this fish, the water it was in, was per requirement. And they had to do all that. Again, all this to get ready to make sure these fish and everybody and any of the animals that flew were ready for flight. And so I wanted to show this because Bionetics was a big part of making sure the animals were ready. And then what would happen is they would turn it over to us as when we would together go and do installation into the shuttle. Okay? Why were we flying fish? That's probably a big question. They found that the receptors in these fish, basically the things that can kind of sense gravity, determine up and down, in these fish are very, very similar to humans. Okay, so well, if we fly these fish and we figure out what's going on in 0G with these receptors on fish, then we can apply it to humans and help with space sickness, those kind of things. So that was one of the reasons why we flew these fish on Spacelab J. Okay. We had hornets fly. This is just a picture of the hornets that were contained. Yes, they did not, the thing did not break, and the hornets didn't fly all over the shuttle. It was all contained. So yeah, that was very successful. Okay. All right, this is a picture when we're doing some of the troubleshooting inside the module. You can see kind of the racks there and the people, and the floorboard would come up there. You can see the floor panel raised, and they're looking in and doing some work. The gentleman in the blue there is one of our good friends, Byron Bonds, who actually works at Teledyne Brown, still works at Teledyne Brown, and they supported a lot of the Spacelab missions. So let me grab a drink of water here. So this is a good picture of Byron basically doing work. And usually poor Byron, whenever he got called, there was usually a problem he had to go solve. So this is basically a picture of something that went wrong, and Byron's there to try to kind of help out. So I wanted to show that, some of the work we're doing to get the space ready. All right, once all that's done, and we leave the operations and checkout building, we head over to the orbiter processing facility. And here's the picture of Spacelab J going into the shuttle. Okay, and this again was repeated for all the payload missions, all the Spacelab missions. And again, following the flight, the reverse of this would happen. So I just want to get you a picture of what it looked like as it's going into the shuttle there. Okay. All right, one of the problems we came up with or found was that some of the equipment that was supposed to go, this is the gangplank that went from basically the pad structure to the white room. The device that it rolled on was too wide. It wouldn't fit down this gangplank, so we had to come up with an alternate method to put this in. So this is, I just wanted to do a picture of that. One thing, like a couple of things I wanted to bring up too. When we were working to get this hardware ready for a mission, a number of individuals actually had to fly to Japan. Cindy Martin Brennan, Bruce Morris were a couple of our level 4 electrical and mechanical group and computer software that actually had to go to Japan. Okay, well, there's an experiment that's going to fly in the shuttle. It's being developed in Japan. So our people would fly there to learn about the experiment. You know, of course, get to learn as much as they can about it. So, of course, when it comes to Kennedy, they know how the experiment works, and then integrating that with the other experiments and integrating with the subsystems of the Spacelab. That was kind of our job. So it was a very important that they went over there. Now, Cindy, of course, a very smart, very sharp, very young female engineer, computer science expert. When she went to Japan, they weren't used to, at that time, that was early 90s, female in a technical role. Now, they treated her pure professional. Everything was good. It was just, you could tell it was a little different for them, for the Japanese. But everything went fine. One neat story was she was an avid hiker. And so, they would go there to work, but she just needed one afternoon just to take a break. So she went on a nice long hike. Well, they really wanted somebody from their country to basically be with her to make sure everything would go okay. Well, this poor gentleman that they had follow her and help her out wasn't much of a hiker. So basically she kind of wore him out. But they didn't complain. That gentleman just did his thing. But she says, yeah, by the time the hike was over, you can tell the poor gentleman was spent. But he never told her about it. Another thing that happened with another story, a couple stories, Bruce Morris, who actually went to Japan as well to be with Cindy. When they came back, when the hardware comes to Kennedy, it's called, with the documentation called the data pack. And in this data pack, it tells you this is everything that's coming with the hardware. Okay, and that happened basically every mission. There'd be a turnover. There's all this documentation and stuff. Hey, this is what it looks like. This is what what we're giving to you. Well, the Japanese were very, very efficient. At that time, there was all these requirements that they needed to provide documentation to us. We needed to provide documentation to them. Well, what had happened was over the course of the years, some of those items that we were supposed to provide got deleted. Well, never got deleted from the documentation list. So the Japanese, being very, very efficient, they turned everything they were supposed to turn over, and they started asking us for our stuff. And it's like, oops, there's some of the stuff that's like, well, no, we don't use that anymore. And it didn't get removed from the documentation. So knowing the Japanese, they kind of just dealt with it, and we went with it. But it was interesting. Of course, we got that updated for later on missions. But another thing about the Japanese, which again, when we worked with all the cultures all over the world, the Japanese, another thing we learned early on was we would ask questions, okay? And the Japanese would say, yes, okay. Okay, that was good. So next question, yes. Oh, okay, this is going pretty simple. Okay, next question, yes. And we start, something's not right here. I mean, they're answering yes to everything. So we want to make sure that the communication, there wasn't something going on there, communicating between the two. Well, we come to find out that their yes meant yes, they understood the question, not yes to the question. So what they would do is they would say, yes, we understand the question, we'll go off. And they basically have a team that then will come back with the answer. So we learned real quick that yes didn't mean yes in our American. It was basically yes, they understood. And then they would come back with a yes or no later once they kind of group talked about it. A couple other things that was really interesting was, of course, they would do, one of our other engineers, let me go dig through here, was Tia Ferguson now. She'd get there in the morning, and every morning they would do the calisthenics. They'd be out in the parking lot or out behind the building, all lined up, all doing their calisthenics in the morning before they started the day. Happened every day. It was just something really neat to see them do that. That's just a couple other things. Oh, one other thing too, another one of our engineers, Tracy Gill, who worked this, he was actually working 2 other Spacelab module missions at the same time. He was working the International Microgravity Lab and the United States Microgravity Lab, as well as Spacelab J. At this point, we were really cranking through. The manifest is just ramping up until there's literally 3 Spacelab module missions in the flow at the same time. Poor Tracy went to one of these meetings, and they start talking module mission. It's like, oh, which module are you talking about? Because everyone was specific and everyone had its own unique requirements. But we had to make sure that, yes, this is the mission we're talking about. So the poor guy, he ran into things like that, working 3 missions at one time. And that's kind of what we did. It was just, we worked, 12, 16-hour days. It was just what it took to get the job done. Let me see if there's any other stories I can tell here. I think that was it. Okay, now getting into the work. Okay, this is actually, again, this is the gangplank going to the White Room. That then, with these fish and a lot of animals, we would have to put them in late in the count. We couldn't put them in there months ahead of time. We basically put them in hours before the launch, just because the requirement was to get them in as late as possible. Well, how do you do that now with the shuttle, the pad, and all that? And so what we're going to do is we're going to show here kind of what we had a device called a Module Vertical Access Kit. And this is a shuttle, of course, vertical to launch pad. And what we do is we'll just use it for this example of the fish. We bring the fish down this gangplank, bring them into the mid-deck area here, then we put them on these, basically it's a crane. There's actually 3 of them in there, but there would be a crane. We lower it down from the mid-deck to what we call the joggle. You see the tunnel area there, and you see the box that's being lowered down. There's a joggle tech there to kind of get it through that 290 degrees. And then we had a gentleman, one of our technicians from Boeing, hanging on a cable that would then, the fish would come down, and he would then install those into the module. Okay, he's hanging from this thing, putting these fish in as late as we could in the flow. Again, it's called Module Vertical Access Kit. And we had to do this for a number of missions. This would be the Spacelab J would be one of them. The first one we did was Spacelab 3, and we talked about that a few months ago. And so it was a very critical operation, because this has happened within hours before launch. And of course, if you mess it up, you slip launch. But luckily, everything was very successful. Now, prepping these things, one of the things that were required, of course, was that they had to be in water. Okay, one of our engineers, Alex Mango, he was responsible for making sure the proper amount of water was in these enclosures before the fish went in the orbiter. Well, how do you do that? You can't power it up and all this. So what they did is they had this, basically it was a Allen wrench with a little piece of red tape on it, and he put this in the hole, and if the water went up to the red tape, then you were fine. You had enough water. If not, he would have to add water. And he did. Actually, one of the times when they had to service it, he actually had to add water, which is basically you just put water in a syringe, and you basically fill up this water. Well, the Japanese, very concerned about the fish, said you have to put it in there very slow, because they're worried about the pressure of the new water going in, damaging the fish's eardrums, I guess, or whatever. And so that was something that Alex basically took his time with. People didn't like it because it was taking too long, but he says, hey, this is what they told me to do. And so he did. And so once we got all that done, we had the proper amount of water, everything was ready, the fish are ready, then we would go into the module for MVAC operations and put it in for launch. And it was very successful, and it worked. So I just wanted to bring that up to anybody. Okay, now this is one of the shots on orbit. This is the crew. Again, a fun shot kind of showing Spacelab J, the inside of the module, and all the stuff that it took. Everything that went into that module to make it successful. And then here's kind of a fisheye one, which I thought was really, really neat. Okay. I'm going to take a break here real quick. I want to do a shout out to some of the people that are watching and listening in. Ben Husset, William
Whiting.
Tom Usack. Usack. Sorry if I'm butchering your name here. I'm very, very bad with names. Mark Chun. And then Dave Stange. Thank you all very much for watching in. Really appreciate that. Yeah, and everybody else that's out there. Hoping it's understanding. Again, if you have any questions or comments, please submit them. Put them in. But this is kind of, I wanted to show this one. This is just kind of a very interesting picture because it shows, of course, a fisheye. But you notice the loops there. Of course, on the ground, we didn't need these. But you can see the crew. How do they keep them floating around but still working in front of the rack? That's all those loops, those white loops you see. They would hook their feet in. You see them sitting there. And that way they would be staying kind of focused on the rack and the experiment that they'd be working on. So I wanted to kind of show that. It didn't really show in a lot of the photographs. But you can see just how packed this module is. So yeah, I have a lot of very successful experiments that flew on that. And again, it was a joint American-Japanese flight. Very successful flight. Okay? And I think this... Okay, now what happens, of course, after the flight? And this is a picture of our group, the tall gentleman on the left. There's Dan Schultz. He was one of our mechanical level 4 engineers that was responsible for post-flight work. He also was responsible for MVAC. He did MVAC as well. And you see the person with the Bionetics Corporation smock on. Again, that's the company, the organization, of course, that helped with any animal handling or whatever it had to be. And one of our main people is Mimi Shu, who's the bottom right there with the dark hair. It's kind of hard to, she's facing the wrong way. But she worked many, many missions. She was in Bionetics. And so this is them basically offloading one of the experiments after the flight. And this a payload van basically was being the cargo in the convoy after the flight. And then, of course, they would offload. And this is just kind of a picture of them doing some post-flight work. So again, we had to worry about things pre-flight, but of course, post-flight, there's a lot of work to do as well. And again, with this being a Spacelab, all that hardware came back to the operations and checkout building. Like normal, we did a reverse. The racks would come out. The racks would go back into the level 4 area. Those individual racks would come off, go back into the rack room, get taken apart, and then prep for the next mission. And so that was kind of a quick run of Spacelab J. Again, there's a number of other experiments, but again, we just don't have enough time to talk about all of them that flew on that. But that's just an example of what we had to do for one of them, which was the fish, which was kind of one of the main experiments that flew on this flight. Okay. And then the last one, I think here, yeah, this is the last one. Again, this is our, this is a website that we've come up with that it's a place for anybody who worked Spacelab to basically tell your story. Okay, if you worked anything on Spacelab, it could be level 4, level 3, 2, pad ops, Bionetics, fish, monkeys, rats, frogs, whatever. This is the place where you can go and tell your story. Fill in, what you did, how you did it, the problems you solved, the problems you encountered, the people you worked with. Again, a lot of these people that we worked with on these missions have been friends for years and still are our friends. So this is kind of a place for you to kind of do that. It's also a place for people who want to learn about what happened can go and read about those same things that those people put in. So it's kind of a dual function. And again, you can see in the bottom left there is the website address for that, where you can go and do that. And again, please, anybody who's out there watching that had worked Spacelab, fill in whatever you did. Put everything in the kitchen sink, throw it down there. So then the other people who come and read that can see the good work that you did. Because a lot of this isn't out there. A lot of people don't know kind of all the work we did for that. And so I think that was the last one, Marty?
Yep.
Yep. So if we got any questions or comments out there.
Yep, no questions.
Okay. Well, I guess with that, we just want to say, excuse me. I talk too much. Well, we just want to say thank you for being here today, everybody, watching in. And stay curious and bridge the space between us. Y'all take care now. Bye-bye.